An arithmetic and geometric series as well. Arithmetic sequences are sequences that have a common difference. Basically, that means you're either adding or subtracting the same amount each time you get to the next number. These are a lot easier to work with than the ones where you have to go -1 to the n plus 1 over n factorial. Those are just mean. These ones are a lot cleaner. It's a lot easier to be defined. There's one generic formula for them to set up, and it's super simple to work with. You guys should be really happy today.
Yay.
I don't sense the happiness. I saw Ben smiled first. That's weird. I've never seen you smile. And it was weird. I don't know if I like it. So, like I said, this is usually one of the easier sections. What Fontana and I decided is that there are some other, a little bit more difficult parts that we're going to put into this, but we'll probably bring that in a little bit with, if we have a little bit of time today. If not, we'll do some more of it tomorrow. So, like I said, this is boring. Arithmetic sequences. You probably remember this from last year. You have the rule, a sub n is the first term plus n minus 1 times your common difference. Where the rule for the nth term, we write it out as a sub n. A sub 1, therefore, is your first term. N just means whatever number term within the sequence. And then D is that common difference. That is one way we write these out. Another way we can write these out is what they call linear form. This is a little bit new. A sub n is going to be your difference times n plus c. That value of c is found, excuse me, this value of c is found by taking your first term and subtract the difference. Okay. And I'll show you how we can write it out both forms with a very simple sequence here in a second. That, what they call linear form, the second one I wrote out, is the real fast way to write it out. The form that we used last year, you guys would substitute in all the values and then distribute and combine like terms. So it took an extra, 30 seconds or so to write out. The other one's a little bit quicker. Okay. Let me show you an example. Yeah, this is the simplified version of that. So when you simplify it out, if you look here, when you distribute, aren't you distributing the d value? And then doesn't this equal a sub 1 plus d times n minus d, which is d n plus a sub 1 minus b, which is that. That's all it is. Does that make sense? Let me show you an example. Super, super, super easy to work with. There's a sequence, and we're going to write the rule for the nth term. And I'll show you both ways. And we might as well write the equation on the board so you can see it also. A sub n is here to save the day. What is your first term? 7. Very good. So your first term is 7. What's your common difference?
I think it's 4.
I think you might be right. How are you able to distinguish ever so quickly that the common difference was 4?
11 minus 7.
Lucky guess? Remember, the easy way to do it is just take the second term, subtract the first, third, subtract the second, and so on and so forth. Don't forget to double check all of it, because sometimes we're sneaky, and we might throw one in there that it might be 3. So therefore, it is not a arithmetic sequence.
Oh.
I know. I know, slime bag, that's me. I might do something like this, 7, 11, 15, 18, 21, 24, and so on, where it makes it look like it's all the same. Is it? Jenna busting out the German.
Yeah.
So, all the German I needed to know I learned from Die Hard. Schnell, schnell! It's true.
It's a good movie.
It's a great movie. I dare you to find a better Christmas movie.
See?
It is a Christmas movie.
I know, that's what I'm saying.
Somebody told me it wasn't.
Well, then they're liars.
It's no Home Alone.
There's
I'm pretty sure it's Mark.
It's no.
Why would I tell you that?
distribute. And then combine like terms. And you get that equation. That's how you did it last year. I'm hoping most of you guys remember that. The other way was to go right into this, into that form, where you just have to figure out what C is. C is going to be your first term, subtract the difference. Therefore, your rule is A sub n is 4 times n plus 3.
No, that's nifty.
It is nifty. You know what else is nifty? The 50 nifty United States.
Oh, that is nifty. That's
So the
nice.
13 original colonies.
Seriously?
Oh,
I ignored your mouth.
How many days left?
32.
But it was counting.
Too many.
32 days.
What's that? Anything? Sorry, we were distracted with the party.
Oh, yeah.
It is. And guys, there's no, I mean, either way, it works out the same way. You're going to get the same result. There are times, one way, when we have to find that first term, where you're going to be given like the third term and the fifth term, and you have to work through to try to find the common difference and stuff. We're still going to have to use the nth rule. But a lot of times, if you just have to write out the rule right away, it's so much quicker to use what they call the linear method, just so you guys know. Other parts of these, no, we just did one, that's too easy. So let's look at this. Let's say a sub 4 is 20, and then a sub 13 is 65. Let's write out the rule. In order for us to be able to do this, we have to know whether it's arithmetic or geometric. The instruction said arithmetic, so I know I have to use arithmetic stuff. If it says it later on after we do geometric, we're going to do kind of the same scenario. You still have to know that it's geometric because you'll follow the geometric patterns to do this. So what we do here is we write it out, and this is much easier to do via the nth rule setup, where you write it out as a sub n and do the long form. Excuse me. And what we do is we try to set it up as two separate equations so we can see what we're going to work out with. So we know that the generic rule is a sub n is your first term plus n minus 1 times your common difference. And I do it again on the other side. And in here then, I know that I have the fourth term, and I know that I have the 13th term. So that means my nth value is going to be 4. So a sub 4 is still going to be the first term plus 4 minus 1 times my common difference. In this case, the fourth term was 20, so I know I have 20 equals the first term plus 3 times d. All right with that? Do the exact same thing on the other side, with the other one. We know that we have the 13th term. It's still going to be the first term plus now 13 minus 1 times the common difference. And what is the 13th term? 65. Is the first term plus 12 times d. And here's where we wind up. We have two equations with two variables. It's setting us up to do a system of equations. And notice what, which variable we're going to be able to eliminate. A. Here's what I would do. I would take the second equation, write it down first. 65 is a sub 1 plus 12d. And below that, I'm going to write 20 is the first term plus 3d. And I'm going to use an elimination method to get rid of a. Just subtract the two equations together. You guys remember doing systems equations? Long time ago.
I don't remember how to do it.
Well, if I subtract all these, I get 45 is 9 times d. What's the common difference? I think you're right. 5 is my common difference. I still need to figure out what my first term is. So what do? It's a 5. Yeah. All I do is just substitute back in and solve for a. So 20, which means my first term is 5. Therefore, I have my first term and my common difference. Does it matter which of these two I use to write out the generic rule then? Which one's easier to write it out then? The second one will be. Because my first term here is 5, my common difference is 5, so what's C? 0. So my rule is a sub n is 5 times n. There's your answer. So sometimes you'll have that, you'll be given two separate values, and you'll write out the equation given that by doing a quick little system of equations. There's other ways to do that. Elimination is always the quickest. Otherwise, if you do substitution, you got to solve for one, you got to substitute back in and do all that other junk. Elimination is just much quicker. Okay? Geometric, when we do that stuff probably Friday, you'll see that substitution is easier. But with arithmetic, elimination is the way to go. We'll give you one of those to try. Can I go to a clean one? So let's say the 8th term is 26 and the 12th term is 42. Take a minute, write out the rule. After you substitute in, you should probably get those two, I would imagine. When you eliminate out, you're going to get 16 equals 4 times d, so d is 4. Substitute back in here. First term, you've got -2, which gives you a c value, -2 minus 4, -6. Nth term is 4n minus 6. Look, linear problems. What equation? What's that? Yeah, it's just additive. It's just additive. It's technically because when you write out equations, you always go with the highest degree, highest power with variables and work your way down. If you wrote -6 plus 4n, you're not wrong. It's just more proper to put it first. You wouldn't write mx plus b as b plus mx, would you?
Oh,
No, this isn't Soviet Russia. That's all. Doing this a little bit weirdly then. Let's look at it with the recursion stuff. Remember we talked about recursive stuff. And recursive stuff depends upon, is written from the previous terms. So each one of them is written out. So what we want to try to figure out is what is the 9th term of a sequence that begins with a 2 and ends in a 9. So we got to figure out how are you going to get to that. Yeah. What's that? Oh yeah, that's fine. Oh yeah. You guys got park stuff going right now? Anybody got to go? Good riddance.
I forgot.
Good luck. That's fine. Yeah, because you guys don't you guys have to eat now?
I will. No.
Oh, you ate already? I hope. Okay. Good luck on your test.
I don't want to take it.
How was Humanities 3 one? I've never seen it. Anybody else? It's great.
Yeah.
A lot of great essays, I'm assuming.
Oh, you gifted it?
I'll make a great essay.
re-gift the gift that we did.
Good luck with it. Make sure you spell check.
I will.
All right. You want to look like a crazy person.
I thought I just like drifted over to my side. I'll take it.
Oh, I'm sorry, not ends with. Begins with 2 and 9. Sorry. Sorry, these are the next 2 consecutive terms. I'm sorry. I read that wrong. It begins with the 2 numbers of 2, then 9. So if these are the first 2 numbers, what's the common difference? 7. So your first term is 2, and your common difference has got to be 7. Isn't that enough to write out the equation? Okay. So what's your C value? Yeah, it'd be 2 minus 7, so it would be -5. So the equation would have been, your nth term would have been 7n minus 5. Now they were asking us to write what is the 9th term in that sequence. That means your n value is 9. So remember this one? 7 times 9. Ready?
Oh, God.
It's
63.
7. That's right. I counted 6, not 7. Apparently I can't count. But this is already a known fact.
SMRT.
That's me. So even if you're given a recursive setup, that means they're going to give you the first 2 terms in the sequence, which means you need to figure out the difference between 2 terms.
Wow.
I know. Pace yourself. You want to pull a hammy. Yeah, keep on finding the 9, because it'll say, what is a sub 9? I hate when they're using a's in the 9. It's asking what's the 9th term of the sequence that starts with 2 and 9. That's it. Yep, that's it. So 63 minus 5 is what? 58?
Sure.
Then let's look at the sum stuff, or oh wait, how many of you guys are gonna be gone tomorrow for this testing? Woo! let's stop that. It's gonna be a lot because these guys are all gone. We'll do the finites. We'll do the summation stuff of this tomorrow, and then the sum of the. We'll do that tomorrow so everybody gets caught up. Because that way it's not too much for everybody to figure out. You should be able to. I mean, honestly, you've done this. You should be able to apply for the first whole chunk of this. We'll just go from here and start tomorrow.